Hello everyone. In this video we're going to be solving a differential equation. We have y prime equals 1 plus 2 over y minus x, and we're going to be solving for y. I'll be presenting two approaches, even though one of the approaches will probably be not complete, but at least I'll show you something. So let's start with the first one. I can go ahead and make a common denominator. Y prime equals y minus x plus 2 divided by y minus x. And then what I like to do next is cross multiplication. Y prime multiplied by y minus x equals y minus x plus 2. Now, in this case, I could probably solve for y minus x, but do you think that's going to help us in any way? We'll find out in a little bit. But first of all, I want to look at this problem from a linearity perspective. Do you think this equation is a linear differential equation or is it nonlinear? As you know, if you have y or derivatives of y to the first power, then you basically have a linear equation. But if y is multiplied by y, or y prime is multiplied by itself, or any other derivatives such as y times y prime, this equation is not going to be linear. And nonlinear equations obviously are harder to solve. There are various methods which we're not going to get into, so we're going to leave it at that. But if you know of any good method that will solve this equation, please let us know in the comment section down below. So let's continue with the second method. So the second method actually uses the idea of keeping y and x together in the form of y minus x. So we're going to use a very, very powerful method. Did you know that? Substitution is very powerful. Yes, exactly. That's what we're going to use. So I'm going to go ahead and call this u. Obviously, you can use any variable you want. You can use a t, you can use a z, whatever, but I just want to use u. I don't want to use u, but I just want to use u as a variable. Okay? I hope that makes sense. So this gives us y prime equals 1 plus 2 over u. But also we get y minus x equals u. So kind of like it turns into a system, which we can differentiate, right? Obviously, because I have y prime here and I would like to get rid of that. I want to write everything in terms of u and x because I'm changing the variable to y from y to u. Then we should not have any y's in the equation. Otherwise, that's going to be very confusing. So hopefully you understand why we need to get rid of y. Okay? And to do that, that's actually pretty easy. Differentiate both sides. You're going to get y prime minus the derivative of x is 1 equals u prime. Now you got to remember, because y is a function of x, y minus x is also a function of x. So I can kind of write u as u of x, which means it's a function of x, which means I can differentiate it with respect to x. Even though I'm not writing it explicitly, this equation means dy over dx minus 1 equals du over dx. Same idea. But these are just good shortcuts and we don't really need to worry about it because y and u are functions of a single variable, so we don't have to worry about partial derivatives and all that stuff. Okay? So far so good? Okay. Now here's what we're going to do. We're going to go ahead and use that information here. But I have y prime minus 1. Well, you can subtract 1 or you can just do this. Add 1 to both sides and then replace y prime with this directly. Make sense? Okay. Replace y prime with u prime plus 1 from here. And that equals 1 plus 2 over u. How convenient. 1 cancels out, right? And we end up with u prime is 2 over u. Can you think of a function whose derivative equals 2 divided by the function? You may not be able to. That's perfectly fine. It's sometimes hard. But you don't have to, by the way. You can just write this. Now, this is the time to use the d notation. Write this as du over dx because you're about to witness a separable differential equation, right? A separable differential equation, which means we can separate the variables on either side, which is very easily solvable. Obviously, if one of the functions is not easily integrable, whatever, it's easy to integrate. It may not be easy to integrate. In that case, we're going to leave it as an integral. Too bad. But in this case, I can do this. u du equals 2 dx. Awesome. And now we're going to we're going to integrate both sides, and u du is going to be u squared divided by 2, and 2 dx is going to be 2x plus a constant. Awesome. Obviously, you want to get u by itself so that you can back substitute. So multiply both sides by 2, you get 4x plus 2c. Hopefully you see what I see, 2c or not 2c. Sorry if I'm overdoing it, but 2c is a constant because c is a constant, so I can just replace it with k. There's no need to have a 2 there. It just looks better. You know, mathematicians, I'm not a mathematician by the way, and they are usually obsessed with these kinds of things, so they just keep converting. Anyways, u squared equals 4x plus k should give us a good solution as long as we replace u with what it is. What is u? What are you? No, it's not what are you or who are you. It's what is you. U is, it's like, what is wrong with you? U is y minus x, right? So let's back substitute. Y minus x equals 4x plus k. Wait a minute, it's supposed to be squared, right? Yay. Okay, great. Now, obviously, the ideal would be to get the y by itself. It's not always possible. Sometimes you get so implicit that x and y are just interwoven together just like crazy. You can't extract it. Anyways, in this case, it is possible. You can square root both sides, considering the plus minus sign or the absolute value, whatever. And then you're going to be able to get y by itself. And you can write y as x plus minus the square root of 4x plus k. K is a constant. It can be 0. It can be anything real. Can it be complex? Probably. But anyways, so this is our solution. Now, one thing that you don't have to do, but you can do is take one of these solutions, like the plus 1, doesn't matter. And you could even set something for k if you want, but no big deal. Now let's go ahead and test it out. Is this really a solution? Are you sure about that? Well, our original problem said y prime is equal to 1 plus 2 over y minus x. And then we're going to go ahead and differentiate this, which is y, right? If we differentiate y, you're going to get y prime, which is 1. And the derivative of the radical function, remember that there's a shortcut. If you differentiate square root of u, you get u prime divided by 2 root u, right? That comes from the power rule. But it becomes the derivative of the inside, which is 4, divided by 2 times the square root of the same thing, right? This simplifies a little bit, leaving us with 1 plus 2 over the square root of 4x plus k. Now take a good look. This is the square root of 4x plus k. That is actually the same thing as y minus x, isn't it? So now from here, square root of 4x plus k based on my solution is equivalent to y minus x. Now I can replace that with y minus x, and guess what? My solution checks. Do you think the other solution is also going to check? That's for you to find out. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.